So Dave Wright, who you've met before, the founder of SolidFire, founder of Jungle Disk. Hey Dave, I've got a question for you.
Sure.
I assume, but I've never actually asked you this, I assume that your experience at, oh man, what was your video game company?
Oh. GameSpy.
The GameSpy was part of what inspired you to go, God, I wish I could buy this product that you then went and invented at Jungle Disk and then SolidFire, but I never actually asked you if that was the case.
Well, it was to some extent. A lot of what we were doing at GameSpy involved building complex back-end systems for video games, and actually the part of it that fascinated me as much as anything is we were spending a tremendous amount of time and effort buying gear, installing gear, configuring gear, running a data center, and then this whole cloud thing happened, and I said, wow, it'd be great if I didn't have to do that, because that is not what we're really good at. And
I assume that. One of the things that I just find as an interesting trend, people building products for themselves. Like there's one thing, you go hire a team and program managers and like marketing people and like you do all of this stuff, right? Sort of the normal IBM way. People developing products for themselves, like Joe saying, I just wanted a virtual machine so I could do my engineering work faster. Or Dave saying, here I was trying to run this game startup and I'm screwing around with all this disk storage stuff. If only this, like people building the product they wish they could have buy that they wanted, that's the coolest stuff in my opinion. Like that's the origin of the Spark. So I'd never asked you that question, but seeing what you built, I had a hunch.
Isn't that half of the open source movement?
Of course.
Yeah. Absolutely.
More than half.
Some of us are just capitalists and not communists, so.
That's why open source ERP is not the hottest area. Like,
yeah.
yeah, just about my kid in high school just like always lusted after ERP.
Or documentation.
Well, so it's exciting to be here and present to this group for effectively a third time in SolidFire's history at a pretty interesting junction in our history. I'm not going to spend a lot of time today talking about SolidFire's architecture, SolidFire's product, our feature set. We've talked about that. The videos are online apparently, so that they're the featured videos on Tech Field Day, so you can go check those out if you haven't seen them. We're also not going to do a lot of new announcements for SolidFire today. We've got an Analyst Day coming up in a couple of months where we're saving some of the announcements around that, but you've already heard, I think in the earlier presentations, some of the things that are starting to come together with NetApp. What NetApp asked me to talk about was NetApp's all-flash portfolio and how SolidFire fits within that, and Dave Hitz opened up the session talking a little bit about the different flash products and the different strengths of each of them. Now, knowing this audience, I didn't think this would be particularly interesting, so I decided to change it up a little bit. And, and I figured I
love you, Dave.
I'm at a unique position in that I wasn't at NetApp, I was at a startup, and now I'm at NetApp. And we've sold the company. We're part of a bigger company here, but more importantly, the check is cleared. And so I can finally come clean, and I can talk about the lies that flash storage companies tell. I have shared a few of these half-truths in the past. They are spread by other companies out there in the market. But I do think that I have a unique perspective, both as a company that competed as a standalone storage, flash storage company, and now as a division or a product line within a broader flash portfolio to really understand the broader truth, if you will, about the flash market, if there is such a thing. So I'm going to be talking a little bit about some of the lies or maybe just misconceptions that I think some folks have about flash storage. And then second special bonus, because I'm sure folks have questions about the acquisition, about SolidFire's role within NetApp, about why I'm here and not in a beach in Costa Rica. So we're going to have a special Reddit-style Ask Me Anything here at the end, and you guys can ask me whatever you want. About SolidFire, about the journey for SolidFire, about the integration into NetApp. We'll save plenty of time for that at the end. But starting with the lies. So the first one I want to talk about is the idea that disk architectures can't be adapted to all flash. And I'm at least partially guilty here. Actually, if you see my my last Tech Field Day presentation where I talked about the difference between ground-up all-flash architecture is I started with the premise that, yeah, we're not even going to talk about those legacy architectures because they can't really be adapted to flash. And there's a bunch of reasons that people give for this. They say that there's challenges of adopting an architecture that was built for disk to flash because you've got to add data reduction. To make flash cost effective, you really have to have data reduction. There's complex metadata handling that goes along with that. And that's really hard if you didn't build around that to begin with. You've got to deal with the fact that flash is a different media. You've got wear and amplification issues that if you just stuff it in and treat it like a disk, you're going to kill the flash and nobody will buy that storage system. You've got code that has been developed over many years and was designed around the latency characteristics of disk, and you've got these long code paths, and you're going to get horrible latency if you just put flash into a disk-based system. And of course, the idea that a traditional dual controller monolithic architecture is forever going to be bottlenecked at that controller when it comes to flash performance, and you have to have some kind of scale-out capability to deliver the promise of flash. So I want to address each of these in turn briefly. So adding data reduction and metadata handling, you can't just bolt it on. And I think that is true. Architectures that really weren't designed from the beginning with really rich metadata support, variable block support, variable I/O support, it is complex to add all of that after the fact. You're basically rewriting your operating system at that point. But I think NetApp's in a unique position because if you look at ONTAP, and particularly the Waffle file system that underlies that, you have what is fundamentally one of the most robust file systems that's ever been developed for storage, which has extremely rich metadata capabilities. And if you look at the history of that product, it actually has not necessarily trailed in data reduction. It's actually been the leader as one of the first products to have deduplication in a primary storage system back in 2006, as one of the first products to have inline compression for primary storage in 2010. And then last year they rounded it out, adding inline deduplication in 2015, leveraging some of the technology that had been developed for the Mars project. And so the reality is, yes, that is hard to bolt on, but people are doing it. We're seeing data reduction show up in other disk products right now. VNX has pieces of this. 3PAR has deduplication now. VSP added inline compression to their flash media. And so it is possible to do, and particularly when you have an architecture built around a rich file system like Waffle, you can add these capabilities, and NetApp has been doing that for many years now. So while there certainly are other products like E-Series that have a fundamentally different operating system and approach and probably won't get a rich array of data reduction features anytime soon, we are seeing data reduction make its way into disk architectures over time. So the second thing that often gets thrown at disk architectures is that you've got to rewrite your whole storage layer for flash. You've got to design a ground-up, log-structured file system to write to flash efficiently and manage the wear. And that's certainly what we did at SolidFire. That's what Pure and others have done. But that's actually not the only way to do it. The truth is that you can just get a better, more expensive SSD with a bit more internal overprovisioning, and it will manage that log structuring, manage the wear management, manage the write amplification pretty darn effectively, especially these days. The controllers have gotten very good at that. And the truth is, as you know if you watch my last presentation, some ground-up flash architectures like Extreme IO, they do this anyway. They didn't actually bother writing a flash file system. They just treat it like a block device and write wherever the heck they want. So,
can I make a comment?
Yeah.
We did not design, I'm the guy that wrote Waffle. I did not design Waffle for flash, but it is to me an amazing coincidence that the architecture of Waffle with the logs streaming out style of data is pretty similar to what more modern companies are doing to achieve these goals. And while the write allocation policies that we had originally were designed to do RAID, nothing about the file system layout, the pointers, the way the metadata works, nothing about that depends on, oh, it has to be laid out for RAID. We can lay it out instead to reduce load leveling. So that doesn't mean all that work's already finished, but the underlying architecture is sitting there nicely positioned.
Exactly. I want to take a quick sidebar because this is a topic I think is good to help educate folks on, because I think there's a lot of misdirection about this from different flash companies as well. And that is, what's the deal with CMLC, TMLC, EMLC, over-provisioning, usable capacity? What's actually happening in all this? And partially people are using these different technologies and describing them in different ways to their advantage, and I think partially it's the fact that some of these things have changed over time. But the reality is that there's not really a single definition between what CMLC and EMLC is. It actually is, at the end of the day, mostly the same chips coming from the same fabs. In some cases, it's defined by, hey, there's different flash media and different lithography that has different fundamental endurance characteristics, and you put one type of media in one drive and one type of media in another drive. We used to have SLC, nobody ships that anymore. But you still have 2-bit MLC, 3-bit TLC, planar NAND, 3D NAND, 14 nanometer, 19 nanometer, 25 nanometer, and these all have different wear characteristics, and which of those you use will have a bearing on the endurance capabilities of the drive. Technologies like power loss protection. Most drives these days have power loss protection. When they acknowledge a write, they won't lose that write even if you lose data, but some really, really cheap low-end drives don't have that. The amount of internal over-provisioning that the drives have, and that speaks to how much space effectively the drive controller has to more efficiently write to the flash, reduce write amplification, and reduce the performance impact of garbage collection on the drive. Again, that is typically one of the big differences between enterprise MLC drives and consumer MLC drives. And then fundamentally the flash controller, how good a controller it is, the code that's running on that controller, how much DRAM it has to manage mapping and page mapping tables and things like that. All of these factors combine to give drives that in the market today have a huge range of endurance, anywhere from as low as 0.3 drive writes per day to 10 drive writes per day. You can just bang the heck out of that and you're never going to knock it over. And that's, at the end of the day, the most important thing to kind of look at is what's the endurance rating for these drives. That's kind of how you tell effectively the quality of these drives. But the interesting thing is that ends up having no bearing to the endurance of that drive within a given storage system. Because how the storage system writes to the drive, how it manages garbage collection and recycling at the system level, all of that stuff is going to effectively change the endurance characteristics of those media. So people that are trying to look at, oh, this vendor uses this drive and they claim this endurance and therefore that storage system is going to have this kind of wear characteristic, there's really no way to do that effectively. At the end of the day, you're going to have to trust your vendors. You're going to have to trust that they've tested the drives, that they understand the wear characteristics, and that they're willing to warranty it for whatever life you plan to use that drive. But arguing over which drive you use and how that drive is configured, when it makes its way into an actual storage system really doesn't matter that much.
One of the things that we saw this week from another event that went on at the beginning of this week was a new product, and the discussion there said that you didn't need to bother buying drives, you could just use the NAND directly. And there seems to be a real difference of opinion, and people saying it's really easy or it's really hard. And obviously people have taken different approaches. I'd be just interested to hear what
and that's certainly not a new idea. If you look at the first flash arrays on the market from guys like Violin, their whole idea was, no, they're flash, we're going to treat it like memory. You're going to, we're going to buy the chips and we're going to build our own controller and we're going to put them in a special form factor. And what happened? Well, number one, you ended up with proprietary hardware that there was a real cost to building and supporting. And every new generation of NAND, you're having to update your controllers and update your hardware and chase that tail. Meanwhile, the rest of the industry, there's multiple vendors. They're moving forward very quickly. They're delivering in standard form factors, and there's a lot of choice there. It's, again, easy to look at any one generation in time and say, you know what, if I design my own hardware right now, I can get ahead of the curve, and I can get better cost economics, and I can stop paying margin to these SSD vendors who are just overhead. But another generation later, another generation later, another generation later, there's a lot of cost that piles up from doing that. So I think the jury's still out on whether that approach is truly advantaged or not. I think it's, can you do that? Can you design your own flash hardware? Yes. Can you design your own flash controllers? Yes. Is there value in that? Probably not. And I'll talk more about that when I talk about flash architectures here in a minute. But certainly from SolidFire's view, that flies in the face of the direction the rest of the data center is going. The rest of the data center is going to commodity hardware, white box systems, software-defined technologies, not proprietary hardware locked up with a single storage operating system with no ability to shop multiple suppliers. And so that is a approach. I don't think it's what we consider to be the right approach. The other thing I want to point out, because again, vendors love to make a big deal about, we use this amount of over-provisioning in our drives, or, we're this efficient with our garbage collection and recycling. The reality is every flash storage system needs space to recycle or garbage collect data efficiently. That's fundamental to the way that flash works, is you need enough spare capacity that you can gather the good data and get rid of the old data. But there's a lot of different ways that you can hide this. You can hide it in the drive capacity itself. Again, the drives that all flash FAS and Extreme IO use, they have that over-provisioning embedded in the drive itself, and the drive controller uses that to do efficient recycling. You can use low over-provisioned drives, but just carve out some reserved capacity in your storage system. Or you can do what SolidFire and 3PAR do, which is you use low over-provisioned drives, but you realize that your system at any given time needs a certain amount of spare capacity in case something fails. And so you can effectively use that unused space for recycling so that you can do efficient recycling. In the small percentage of time that a drive may be failed, your recycling may not be as efficient, but eventually somebody's going to go replace that capacity and you're going to have spare capacity again. And so there's tricks you can play to hide that overhead, but fundamentally everybody takes it somewhere, and nobody is that much better than anybody else when it comes to the efficiency here. All right, coming back to the lies that companies like to tell. So long code paths designed for disk can't deliver flash latency. So, to a certain extent, this is true. You cannot just take a disk array that has never seen this thing called flash, drop flash in it, and be done. But code is fungible. Software is fungible. It can be tuned, rewritten, and optimized. And if you look at one of the big things NetApp's been doing over the last couple of years, it has been rewriting large amounts of their code base. And the other large disk vendors have been doing this as well. We just saw the all-flash VMAX announcement where they said, oh, by the way, we rewrote all the data path code, so it's actually fast now.
Can I give an example?
Sure.
I thought this was just a cool example of how we rewrote it. The old model was, ONTAP is a message passing operating system in which stuff gets queued, and when the disk replied, the request for that disk would get queued. And the queuing delays were no big deal when you just waited 10 milliseconds for the disk to come back. When you waited some number of microseconds for it to come back, putting it on a queuing ended up adding way more delay than what the flash had already done. And so we rewrote the underlying handlers to actually take off the interrupt stack handler all the way through the network and reply to the request. So yes, it's true, we had to do that work, and it radically changed the benchmark results at the far high end of the load. So the answer is, yeah, you can't just drop it in and be done. That is completely correct.
Yeah, but again, this idea that you have to design the architecture from the ground up in order to deliver good latencies, I think is very provably not true. The performance that all flash FAS gets at less than a millisecond of latency, the performance that the EF series gets with a much simpler operating system and a shorter instruction path, again, it's insanely fast. It wasn't designed from the ground up for flash, but it turns out it's a really, really good operating system, especially after the optimization they've done for flash. This idea of monolithic storage controllers as a performance bottleneck. Again, this is something that I certainly slung a lot of arrows at the competition at, selling a scale-out storage systems. And there are fundamental limits there, right? There's only so many cores, and there's only so many ports you can put in that front-end controller, and that will be a bottleneck at some point. But realistically, Moore's Law has helped. Those limits have increased over time. You've got how many cores in FAS 8080?
I don't even know.
120, cores for days. And the limits that you can achieve, even in a dual controller architecture, is more than enough for certainly single application type workloads, over 600,000 IOPS for both AFF and EF series. And then if you can cluster your architecture like AFF, you can go even further. The other reality that a lot of flash companies don't like to talk about is that most users of flash are nowhere near IOPS bound today. These arrays are so fast and so much faster than what they're replacing that even when you put performance-intensive workloads on them, they're nowhere near 100% utilization on these arrays. So a lot of the arguing of who's got the fastest all-flash array, how many hundred thousands of IOPS can you do for this given workload in the field don't really translate to much additional value, because if you need 100,000 IOPS and that's all you need, it doesn't matter whether your array can do 700 or 900 or 5 million IOPS. Most workloads just aren't there today. Maybe they will in the future. Maybe as applications and databases are rewritten to actually utilize flash in a different manner, maybe we will get there. But fundamentally, that's not the bottleneck in the data center today.
The only challenge there is human nature, right? Somebody tweeted, Justin, I agree with that. Have fun telling the customers you don't really need those IOPS that other vendor can offer you.
Yeah. No, it is a challenge, right? I mean, vanity numbers are vanity numbers for a reason.
Isn't that why everybody who made hybrids 2 years ago now has an all-flash version too?
Yeah.
I think there's other reasons that they need all flash as well, but the reality is, and again, I want to separate the idea between, hey, a hybrid array is fast enough for everybody, so you don't need flash, because. And this is something I don't, some people may think this is a lie that flash companies tell. I don't think this is a lie. The reality is hybrid has very different performance characteristics in all flash. It's not about how many IOPS can you do on a hybrid, how many IOPS can you do on flash, how many IOPS does your application require, because all the IOPS on the hybrid system are not evenly distributed. And when you have some IOPS that are 1 millisecond and some that are 20 milliseconds, that leads to a lot of issues in the environment.
Let me echo this. I was a deep skeptic about people saying, well, treat all flash arrays as a completely separate category from ones that can have disk in them. Because it was like, well, then just don't put the disk in it, and then it's all flash.
I already told you not to get me started about your
when our engineers started pushing down the all flash domain, they found performance optimizations to do that only work if it's all flash. They changed some of the underlying scheduling parameters in ways that don't make sense if there's still devices out there that might not come back for 10 or 20 milliseconds. So I was wrong and the engineers were right, that there really are reasons why you might want to make sure not to put any of those old, slow, confusing things on it, much to my surprise. So I just kind of come clean on that.
Yeah, so I don't want to get too far down there, but even though most workloads aren't going to push over most of the all-flash arrays in the market today, there is a very big difference between how workloads perform on hybrid systems versus all-flash. So what about going the other way, right? If you can take a disk-based architecture and make it run flash, what does it actually take to take a ground-up all-flash architecture and make it a fully fledged primary storage array? And this is something that I think a lot of startups underestimate, and I would say in SolidFire's case, that was never really our goal. But we certainly got pulled into opportunities where customers said, yeah, I like you for this. By the way, can you also do this? And as you start going through the checklist of features that these enterprise arrays have, you realize it's a long list. And the fact that NetApp has been working on ONTAP for 20 years, they haven't been doing nothing in that time. They've been building a lot of features, and that is a very big wall. And while certainly not a lot of new environments and new workloads and new use cases don't require all of these things, when you talk about I'm going to displace large amounts of enterprise array in an enterprise data center, these things start to matter, and these things take a long time to build. You might say, at the end of the day, it's great that you can adopt a disk architecture for flash. I still want to ground up all flash architecture. It just feels better to me. Let me introduce you to SolidFire. So I think NetApp has, again, they've gone from one end of the spectrum on flash to another. They were early leaders in flash, and then they were clearly behind in the all flash market. They brought their existing disk portfolio up to speed in all flash, and then they added SolidFire to it. And the reality is they have, and we'll talk about the portfolio in a second, they have solutions for whatever you want to do there. My point here is really there was I think a period of time where everybody was counting the big guys out. They were saying NetApp's flash products, they're never going to be competitive. 3PAR, never going to be competitive. VMAX is dead, right? And that may still be true, we'll see. But the reality is that all of these architectures are being adopted to flash. And if they eventually die, it won't be because they didn't have flash or they couldn't use flash. That is not the barrier at the end of the day. And the reality is they've adopted to flash a lot faster than some of these new arrays have been able to catch up on features. And that's why for EMC and all flash VMAX still exists, because Extreme I/O is decades from being able to catch up with the feature set of that product. All right, second one. So one flash architecture can cover all primary storage use cases. This goes to the question of, is there an all-flash array market, right? Do I need a product to attack the all-flash array market because that market is really important and growing, but I really just need one all-flash product? And we've seen different viewpoints on this. And literally in the last week, we've seen one company whose viewpoint suddenly shifted on this because now they have more than one flash architecture. The reality is, I certainly don't believe, and I would say this is not a view I've espoused personally. I've never said that a single flash architecture can handle every use case, deployment model, and workload in the modern data center. And in particular, I think if you break down where flash is being deployed today, there's very different needs that drive you to different architectures in those spaces. So you have traditional enterprise data centers, places where you've got traditional virtualized enterprise applications, centralized management, a bunch of silos by department, application, use case, or project, and you've got a very entrenched storage operating system and storage management paradigm around that. You've got a lot of rich data services that are array-based that you're using that are part of that. That drives a particular architecture to deliver those things.
I mean, you live that personally, because before the acquisition, you displaced NetApp and sold SolidFire at customers, but you couldn't displace all of it. And,
right.
And we were I mean, we've been living this together, right? That you couldn't get us out and we couldn't stop you.
Exactly. And so it goes to my point that there's going to be environments, and even within an enterprise, there's going to be places that they need that 30-page stack of features, or at least some arbitrary subset of them to keep their applications running the way that they want them to run. And it's going to be years and years before they ever remove those dependencies. The second thing we see is a lot of flash is being deployed now just for the speed characteristic. That's certainly where flash first came into the data center. Is I've got a problem child application, I want it to run faster, I want to take it off of my shared storage array, and I want to put it on a dedicated flash device. And that's still a very common way that flash is being deployed. But the type of system you use for that is ultimately going to be very different than what you would want if you had, again, a 30-page stack of features, because that 30-page stack of features is going to, at the end of the day, have some impact on performance, and it certainly is going to come with an added cost of more expensive controllers, or an added cost in higher software licensing. And so if you just want performance, there are definitely architectures that will drive you towards a much lower cost per IOP, and a much smaller footprint to deliver that performance. And then finally, cloud-like infrastructure, obviously an area that's near and dear to my heart, but the idea that, look, we're going to move past silos of storage, and we're going to move into pools of capacity and performance. And we're going to move into a software-based model for dynamically provisioning those across all the workloads in our data center. And this is clearly a huge trend in customers today, and this is effectively the trend that I built SolidFire around. And it's a challenge of scale. And not scale in how big can your storage system be, but scale in, I've got a lot of applications and I need to manage them more efficiently. I have a high velocity of workloads coming in, and in many cases coming out of my infrastructure, and I need to manage that efficiently. I have a scale challenge in the number of possible interactions between these workloads that could exist, and I've got to manage that more effectively. When a customer says, I just can't get my hands around how quickly I need to grow to handle my requirements, that is a scale challenge. And that's fundamentally how we really look at the needs of the market today when it comes to flash, because there's a lot of flash storage systems. If performance is all you want, you can get performance a lot of ways. When you talk to a customer about what their challenge is, it usually falls into one of these buckets. It may be just performance, and that's all they care about. It may be, how do I move my disk architecture to flash with the minimum possible disruption? I want to keep everything running just as it is. I just want everything to be faster. Or it may be, no, I'm fundamentally redoing my data center architecture because I have to move faster. I need more agility. The old way isn't going to cut it. I've got to get automated. I've got to get scale out. And you fundamentally need a different architecture to do that. It would be great to believe that there exists a single architecture to do all of these things, but it just isn't possible. And anybody that claims that they can handle all of these priorities and do them well with one architecture just isn't being true. And so this is now where we actually come back to the NetApp Flash portfolio. I did promise I would work that into it.
Quick question about the portfolio.
Yeah.
I think you've laid out a different use case for each one in that previous slide quite nicely. But in the future, do you see them becoming more converged? Because I understand you're never going to get one product
Sure.
to rule them all. But as the relationship develops between SolidFire and NetApp, could we see it sort of taking on some of the features of ONTAP, or is it going to get more sort of data services that would allow it to move into that space?
Yeah, it's a great question. And look, the reality is, just because we might say that SolidFire is focused on scale and NetApp's focused on all flash FAS is focused on data services, that doesn't mean that SolidFire doesn't have data services, because we have probably the richest array of data services in the native kind of flash array space. Nor does it mean that all flash FAS doesn't scale, because it has clustering up to 32 nodes in a single system. There's clearly overlap in those capabilities, but there's also focus that comes from knowing where that architecture is going to go in the future and what problem you're really trying to solve with that architecture. And so while we will get more data services and all flash FAS will probably get 32 core Intel processors and get more scalability, it will never be the best at scale, and we will never be the best at data services. Now, it may be that over time we grow close enough to that customers who want to make that leap are more capable of doing that. But that is not necessarily the goal. It's not to converge these things over time.
I just want to make an observation. With the EF series, we have very consciously decided it is the race car, and we're not putting certain kinds of things in it. We want to keep it that sort of bare bones, no windshield kind of thing. We are not putting those same kind of constraints on SolidFire. My personal view is, over time, more and more applications will move into next-gen data centers of exactly the style they're building. And in the same way that VMware started out with garbage apps, eventually VMware matured to where the more robust stuff was in there. If you had to ask my hunch, I think the pendulum, over a 5 or 10 year period will be swinging over SolidFire. I'm not sure that's the best investment right now for that product to be investing for the best growth.
Yeah.
Right, more platform 3 and the early stage and next gen data center, but it's not like we're telling these guys don't do it. In fact, have at it. Here's the source code. Take what you want. It's just I don't think that's where they're going to start. But does that distinction make sense? There's a real barrier for how we're viewing the EF. With SolidFire, it's an evolution over time. Manage your market.
Yeah, and look, the reality is, right now with the flash market, this is all boats float in a rising tide. All flash FAS, EF series, they're growing ridiculously fast. SolidFire is growing ridiculously fast. Architecturally, you could argue that over time, more customers are moving that way. But again, that's one of those multi-decade transitions. That's not.
But that's certainly my bet. That's why we bought these guys, because it's a hot and interesting area. They've got the best product for it, right? I mean, it's not like we're trying to slow it down.
I was just going to make an observation, really. If you look at the way that some of the vendors have gone over time, over the last 15, 20 years, they've taken a load of products and they put them into a portfolio, and they've invested absolutely zero amount of time and effort to make the data between those platforms mobile.
Yeah.
Now, that was the start of your conversation, Dave, with
Data fabric.
Some of the stuff around the fabric. And I think the difference now is that mobility piece has become an essential component. And if you've got a portfolio of products with no mobility, then you're still 20 years behind the curve.
You're right on the ball there, right? Which is that the good news for customers that are concerned about, am I investing in the right platform today, and am I locking myself in the wrong kind of solution for tomorrow, is the other half of NetApp's strategy beyond Flash is the data fabric. And the data fabric is all about being able to seamlessly move the right data to the right place at the right time, on-prem, in the right product, into the cloud. So I think that dovetails.
I think the problem you've got is there's going to be significantly high expectation that delivers to the level that we're all thinking it should deliver to.
We understand. We've got to set expectations reasonably, but it is part of the vision here.
And I think the other half of that, and it gets back to the API discussion that we had earlier, if there's a reasonable and logically laid out portfolio of good products, and there's data mobility on the back end, the biggest thing that we have to tackle at that point is how the hell do we manage? Like how do we operate all of that in there? And I think that one of the things that we've seen so far as part of the acquisition and as part of, like Dave Hitz said, here's the source code, go nuts with it. the ease of implementation of some of these things that we want to do on the front end, simply because there's always an API to work with. My hope is that it drives a lot of that integration faster than it would anyway, because like everybody else, I've been in an environment where I've had to manage multiple vendors or different products from the same vendor, and you don't know which version of Java needs to be on the VM to run the UI that came from which acquisition to do what. And I think that I think we're right to focus on the data and the data mobility. We're right to focus on the positioning and which pieces go into the portfolio. But the fun part, I think, for the customer-facing side will be building the operational environment that makes putting the data where it needs to be and moving the data where you want it to as simple as possible.
Yeah, so when I can run a command from a CLI on any of those products that show me one end of the snap mirror to the other, and it all looks the same, I think I'll be happy at that point.
Yep.
Totally agree.
All right, so again, when we look at the landscape and how NetApp's portfolio falls out against this and really what the competitive landscape looks like these days, again, we see products in the market that are very focused on speed. We see products in the market like 3PAR that obviously have a rich array of history and data services. We see products like Pure that really sit in the middle of all of this and don't really, specialize in any of these things. Extreme.io, arguably, if you're going to put it somewhere, maybe it's more towards scale, but also really isn't particularly strong in any of these things. And then you've got NetApp's products. And I think NetApp's products, you can make a compelling case that whether it's speed, data services, or scale, they have the leading product in those segments. And that is really the strength of this portfolio. So I'm not going to spend a whole lot of time on this. The one other thing I would point out, though, is that when it comes to these products and this market segmentation, this differentiation, it's not just the priorities and the use case. In many cases, it's how are the applications being deployed and who's the buyer? Because the way that these data centers are being built is changing. The people you're selling storage to is changing. And in many cases, the people that SolidFire sold to in an account is a completely different buyer than the person that NetApp sold to in that exact same account. One was the storage infrastructure buyer. The other is the cloud architect. And the ability to be able to target these solutions at different buyers, because different people are buying storage now, is really key. The fundamental point, primary storage is just too diverse a market, especially these days, to be served by a single architecture. You ultimately have different priorities you're trying to serve, and spreading one architecture over all of it is going to leave you with a very thin layer of butter over a very big piece of bread. All right, so my last one. So all flash arrays are slowly taking over the disk and hybrid market. Some people repeat this, some of the disk people repeat this, some of the hybrid people repeat this, some of the flash people repeat this. The reality is, it's really happening fast. It's happening a lot faster than I think anybody realizes for primary data. It's happening fast and it's happening at an increasing rate, and the reality is that high capacity MLC flash is just plain cheaper than performance disk. Nobody should be buying 15K disk, nobody is. Nobody should be buying 10K disk anymore. Some people still are. And that becomes more and more apparent as time goes on, and the more apparent it becomes, the less of that performance disk you're gonna see. And even the analysts have finally woken up and are saying, yeah, the technology's mature, it's cost effective, it's actually cheaper than hybrid arrays in everything except raw kind of maximum capacity, but every other metric, it's really more cost effective at this point. It's just a better way to do it. And it's actually happening faster than I think the analysts realize. Again, Gartner just put out a report. They said the percentage data centers using solid state arrays for primary data will increase from 1% last year to 25% in, I think I cut off the last part, in 2020, 5 years from now. This dramatically underestimates the rate of this transition, partially because it basically says this is the percentage of data centers that are only running solid state arrays. And look, it will take time to eventually displace all of that disk that some people are still buying today. It will take many, many years. But in terms of the actual buying and what the new systems people are buying are, it's happening much faster than this. Dave gave a couple of stats at the beginning, and I actually think that the FAS market, the all-flash FAS and kind of the on-tap market is a great proxy for how quickly this shift is happening. Because again, that product was a disk-based product, was a hybrid product, is now an all-flash product, and it was arguably the #1 architecture for primary storage in the data center. So if you look at just how that business is shifting to flash, I think you get an idea at how quickly this is happening. And Dave talked about the acceleration in the revenue there.
This gets right to the question of, is it a separate market? The bulk of what's happening with our all-flash FAS sales is not that it's some entirely whole new market. It's the people we were already selling arrays to said, my next one, I'd like all-flash, please, right? So it is a transition within a market, which is now a $600 million run rate within a $5-6 billion company overall, right? So there we go.
And I'll give a different view of it. And again, I can't give you the number that I would like to give you because this is not a public number, which is, hey, what's the percentage of FAS systems that are all flash configurations? That's a really impressive number that they have decided not to share yet. What I can tell you from the public numbers is it's one thing to take the $600 million run rate and compare it to the $6 billion NetApp business. Oh, it's only 10%. That $6 billion business has a lot of things in it.
It includes other products,
Right.
it includes services,
NetApp's,
all that other stuff.
NetApp's last 12-month configured systems revenue, which is their actual storage system sales, was about $1.9 billion, right? The all-flash run rate is $600 million. Now, these are different numbers comparing different things. For example, the all-flash number includes services, but it also doesn't have SolidFire in there. So you can't extract an exact percentage from these numbers, but this should give you an idea of the order of magnitude of how much flash is becoming a significant part of a business like NetApp and the industry as a whole. So this transition is happening extraordinarily fast. The other thing to point out is the majority of this revenue shift is actually going to the incumbent vendors. That's not to say that some of the startups aren't having success in getting revenue, but when you have billions of dollars of revenue that are shifting, the incumbent vendors are going to capture far more than their fair share of that because that will always be the easiest transition to make. To Dave's point, if you have a fast platform and you want to deploy a flash array, the easiest thing to do is take that platform and deploy a flash version of it. And this shift is happening at a speed that these startups, they can't necessarily reach all of that opportunity. And the flip is going to happen before they have the feature set, they have the field reach, they have the mind share to be able to really be competitive in the majority of these opportunities. And so my prediction, we'll see when the numbers come out in a few weeks, is that incumbents will actually have a higher share of the all-flash array market, for what that is, in 2015 than they did in 2014. And that share will continue to grow over time. So the all-flash data center...
I should cash in all my stock in all those startups?
The all-flash data center is very, very near, is my point. So,
No stock advice.
yeah. I'm sure there's a financial disclaimer somewhere.
I think I'm a smart guy, but there's a line I won't cross.
Yeah. So, these are kind of really the points that I wanted to get across today. Because again, I think you see people taking different positions on these. But I've been on both sides. I've been on the startup side. I've been on the big vendor side. Again, my check is cleared. I have no particular loyalty to say anything other than what I think is the truth, and that is that disk architectures can be adapted to flash. You need multiple architectures. No single architecture can address all of the needs, and this shift is happening really, really fast. So that's it. I hope we have a couple of minutes for questions.
Yeah, how's your cutoff work?
Steve, is it okay to give 5 minutes questions? Yeah. Okay.
There was one that came in earlier about being part of a disk-focused company versus, hey, these other architectures, and like, you've been out in the world in this web scale. Any thoughts on that? I promised to get back to this, so I wanted to.
Yeah, look, I think realistically, NetApp has turned 180 degrees from at least my view of it over the last year or two when it comes to flash, when it comes to cloud. I think Dave's presentation and Joe's presentation earlier today really show you where their head is at on these things, and that's why we were comfortable becoming part of this.
I'll start us off. Do you drive to work in a Ferrari now?
What's that? I do not. That's for the track.
At anything. Will do anything.
Does that mean you're retiring the Porsche?
No. I'm splitting my time.
Broadening the portfolio.
Yes. Portfolio approach, exactly.
Given you're now out of the storage startup game, and I think you did very well on the timing, what do you think, what are your thoughts on the storage market more generally and the prospects for the zillion storage companies that are out there?
Yeah. Well, so I think, number one, the storage market is clearly going through some very big, very impactful transitions. Anytime you go through transitions, that creates opportunities, and that has created opportunities in flash, opportunities in cloud, opportunities in other parts of the storage market. I think we're going to see some great stories come out of this, and I think SolidFire is a great example of that. The reality is, for the last couple of years, I think the storage market was overfunded. The valuations got a little bit ridiculous, as did, frankly, the rest of the market. Storage was certainly not unique in that. And that we've seen a reset happen. And so as a result, we're going to find out what happens when some of these things shake out. But there's going to be success stories. Storage as a whole is still incredibly important. It is in the midst of a transition. There are new things that need to be brought to bear, and new technologies need to be brought to bear, and that does create opportunities. But not everybody is going to make it to the other side, and especially in the funding environment we have today, it's going to get increasingly hard to do that if you don't have a very differentiated product, a unique value proposition, an efficient cost of sales, and the ability to get funding and scale.
As a follow-on question to that then, hyperconverged. Thoughts?
We've always been very interested in hyperconverged because it's at a different end of the market than when SolidFire played historically. We were really large core data center infrastructure. Hyperconverged was this small virtualization branch office environment. But we actually looked at the technologies and said there's a lot of what we do that is what people actually like about hyperconverged. The simplicity of the building blocks, the Lego scaling nature of it, the easy deployment and provisioning and management, single pools of storage, all of that stuff. And so with the right go-to-market, there's an opportunity to take the SolidFire technology and sell it to customers that want the simplicity of hyperconverged, but may actually not like their idea of getting all their compute from their storage vendor, for example. So there's ways to leverage, I think, what SolidFire has within the broader NetApp ecosystem, which has access to channels that we just didn't have, to address a lot of the challenges that hyperconverged is solving for customers today. Because do I need to run my compute on the same processor as my storage? That's not a problem most customers think about. What they think about is how fast can I get time to value? How fast can I deploy new infrastructure and workloads? And the right solutions from SolidFire and NetApp, I think, can help them do that.
Okay. I don't.
All right.
Other Dave? Do you want to
I agree with what Dave just said. My view is when you look at hyperconverged, what's fascinating is how many different interesting things are tangled up in it. And to get your head around what you want to do, you need to untangle it a little bit. One of the really cool things is building big infrastructure out of 1U or 2U boxes you can add incrementally. That's a really interesting way of getting good efficiency and making it easy for the user. A different but related thing is how simple can it be to manage that whole cluster, right? Which is related to the first one, but also very different. A third thing is the question exactly how's the storage and compute laid out. These are way different things that are all getting bundled together in the word hyperconverged, and especially as these things grow out to larger, data center scale as opposed to smaller scale, I think the answers are going to change. So all of those are really interesting. Some of those are the motivations that led to the SolidFire acquisition, right? Because they're very strong in the simplicity piece and the leverage of the underlying off-the-shelf hardware piece. Figuring out the exact right answer for the end of time, we don't know. But yeah, it's a hot, interesting area, and these issues that it addresses are center of mind for customers and well aligned with the technology trends in the industry that you'd want to be riding, right?
So now that there is NetApp with all this file and NFS, SMB, etc., and you have only block actually, and you are looking at new cloud application, scale, containers.
Yep.
They don't have any ability today to access block devices. So when NFS, when object, when...
Well, so, I would argue with some of that. For example, we have container support. We have a Docker plugin. You can put containers on SolidFire. There's no requirement that that be done over the NFS protocol. There are places you need shared file systems in the cloud. That's always been an interesting opportunity. As workloads that are file-based become within the addressable range of flash in terms of cost and capacity, that starts to get more interesting. So we don't have anything to announce on that today, but the nice thing is we are part of the largest NFS serving company in the world, so there's a lot of interesting IP here.
Adam is the product manager, one of the product managers at SolidFire, and as he was coming in during the integration, he said, I feel like a kid in a candy shop. There is so much source code here, so many capabilities here, but the challenge is we want not to drown this team in serving this cool new next generation data center market, right? And so over time, we'll figure out what those customers want, and the team is well positioned to do it. But I don't think I'm nearly as smart on those customers as this man right here, right?
And I can just see Adam too.
Yeah, no, it's like, but like, whoa, slow down. You got a team and a roadmap that was based on what your customers already wanted, right? So let's keep moving there. The highest thing on the list, I have to say, was the Snap Mirror protocol. Let's make the data move, right? That was the one thing we were like, really, how can we help the data move, right? To the point that you guys made. But other than that, it's, customer driven.